no, 12:45, sorry, 12:15 rather, up to 12:45. That's 30 minutes. Okay, I'll just chat that to you so that you know, no, that's really open while they are having their reporting. Okay, let's start. Anna Faith.
Okay, so good afternoon, everyone. We are Group 2, and our report for today is about combination. You may also open your books on page 272 to be able to follow. So, in our previous lesson, we have learned all about permutation, which is the first counting technique, and now we are going to focus on combination. So, what is combination? Take it away, Aliyah.
So combination is a selection of various objects, disregarding the order or the arrangement. But how is it different from permutation? Let us explain it through an example that is Catherine, that is going to be explained by Aliyah.
Suppose we have to find the total number of probable samples of 2 out of 3 objects, y, x, z here. So first of all, you have to understand whether the problem is relevant to the permutation or combination. The only means to find it is check whether the order is necessary or not. If the order is important, then the problem is related to permutation, and the possible number of samples will be xy, yz, yx, zy, xz, and zx. In this case, xy is distinct from the sample, yx, and yz is distinct from the sample, zy, and xz is distinct from the sample z and x. If the order is unnecessary, then the question is relevant to the combination. The possible samples will be XY, YZ, and ZX.
Now that we know about the combination technique, how do we use it in solving problems? Let us first know about the combination rule. The combination rule is all about the number of combinations of n distinct objects taken r at a time is defined as NCR equals n factorial over n minus r factorial, where is where r is less than or equal to n. In other references, NCR is also denoted as CNR, CNR, or simply n over n.
First example, in a local election, voters are to select 6 councillors from the set of candidates. If there are 12 candidates for councillor, how many possible ways can a voter select 6 councillors? In this case, the order of choosing 6 councillors out of 12 candidates does not matter. For instance, choosing candidates. A and B is the same as choosing candidates B and A, hence use the combination rule. 12C6 equals 12 factorial over 12 and 6 factorial 6 factorial. This is equal to 12 factorial since 12 and 6 is equal to 6. It will be over 6 factorial and 6 factorial. Of course, 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial and 6 factorial. Next is we will cancel both 6 factorial. Now we will only have 12 times 11 times 10 times 9 times 8 times 7 over 6 times 5 times 4 times 3 times 2 times 1. If we multiply this, we will get 665,280 over 720. Divide them and the answer is 924. Therefore, there are 924 possible ways to vote for the 6 councillors out of the 12 candidates.
Another example: 7th grade 10 students volunteered to join the promotions committee that will support the projects of the school student council. In how many different ways can 4 students be selected in the promotions committee? You are to select 4 students from a group of 7 students. The order of the 4 students to be selected is not important. Therefore, use the combination rule. The solution will be 7C4 equals 7 factorial over 7 minus 4 factorial 4 factorial. Then it will be 7 factorial over 3 factorial 4 factorial. 7 factorial will be 7 times 6 times 5 times 4 factorial over 3 factorial and 4 factorial. Cancel out 4 factorial, so we have 7 times 6 times 5 over 3 times 2 times 1. Multiply them and we will have 210 over 6. After multiplying, divide and we will have 35 as the answer. In conclusion, there are 35 ways to select 4 students out of the 7 students to be in the promotions committee.
To understand the lesson further, let's discuss another example. Given a standard deck of cards, in how many ways can you select 3 cards? A standard deck of cards is a set of 52 cards with 4 different suits: hearts, diamonds, spades, and clubs, with 4 heart diamond cards are red, whereas spade and club cards are black. Each suit consists of 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, and King. Jack, Queen, and King are called face cards. In selecting three of out of the 52 cards, the arrangement of the three cards does not matter. Since getting an ace of diamonds, seven of hearts, and nine of clubs is the same of getting a seven of hearts, an ace of diamonds, and nine of clubs. Hence, use the combination rule. We will start out having 52C3, 52 factorial over 52 and 3 factorial and 3 factorial. If we subtract 52 and 3, we will have 52 factorial over 49 factorial and 3 factorial. Then 52 times 52, 52 times 51 times 50 times 49 factorial over 49 factorial 3 factorial. Cancel out both 49 factorial and now we will have 52 times 51 times 50 over 3 over 2 times 1. Multiply and now we have 132,600 over 6. Divide them and then the answer will be 22,100. Ways to select the 3 cards from standard deck of cards.
Another one with the same scenario is this. Given a standard deck of cards, in how many ways can you select 5 face cards? A typical deck of cards consists of 52 cards divided into 4 suits: heart, diamond, spades, and clubs. Hearts and diamonds are red, while spades and clubs are black. Each suit has 13 cards: an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Face cards are Jack, Queen, and King. Determine first the total of number of face cards. There are 3 face cards in each suit, and there are 4 suits hence. There are 12 face cards in a standard deck of cards. In selecting 5 out of 12 face cards, the order is not a consideration. Use the combination rule. 12c5 equals 12 factorial over 12 minus 5 factorial, 5 factorial equals 12 factorial over 7 factorial, 5 factorial. 12 factorial is 12 times 11 times 10 times 9 times 8 times 7 factorial over 7 factorial, and factorial cancel 7 factorial, and it will be only 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2 times 1. The answer is 95,040 over 120. Then divide the answer is equals 792.
So for our last example, in the school photography club, there are 10 boys and 8 girls. In how many ways can a committee of 8 people be selected if there must be 6 girls in the group? So this last example will be very challenging. Selecting 8 people with at least 6 girls in the group means that there could be 6, 7, or 8 girls in the complete committee. So when you select 6 out of 8 girls for the committee, this will entail choosing 2 boys to complete the committee of 8 students. Thus, the combination rule and fundamental counting principle, that is 8C, 10C, squared 2. So when you select 7 girls for the committee, this means choosing 1 boy, that is C, combination 1, 1C, 1. So when you select 8 girls for the committee, this means not choosing a boy to be included in the group, that is 8C, 10C, or simply C. Since the situation involves selecting 6, 7, and 8 girls for the committee, and since these events are mutually exclusive, add these possibilities. Note that the word and the mean to the and multiply, and the word means to add. The solution will be 8C6 times 10C2 plus 8C7 times 10C1 plus 8C equals factorial 8 factorial over 2 factorial, 6 factorial times 10 factorial over 8 factorial, 2 factorial plus 8 factorial over 1 factorial, 7 factorial times 10 factorial over 9 factorial, 1 factorial plus 8 factorial over 0 factorial. That makes 8 factorial. If we solve 8 factorial over 2 factorial, 6 factorial will be the answer. That will be 28. Multiply it to the answer of 10 over 8 factorial, 2 factorial, which is 45, so it is 1260. Then add the answers of 8 factorial over 1 factorial, 7 factorial multiplied to the 10 factorial over 9 factorial, 1 factorial. It is 8 times 10 equals 80. Then lastly, add the answer of 8 factorial over 0 factorial, which makes 8 factorial. The answer will be equals to 1. Note that the 0 factorial will always be equal to 1. To summarize it all, 1260 plus 80 plus 1 is 1341. Therefore, there are 1341 ways to select at least 6 girls to be in the committee.
After learning about solving problems and using combination, let us now focus on differentiating a problem that sorry po. After learning about solving problems using combination, let us now focus on differentiating a problem that needs permutation and one that needs combination. For example, choosing three students to form a cleaners group in a class deals with combination. That, that is because there is no importance to the order at which students are chosen. Student A, Student B, and Student C are picked in that order. That is the same thing as Student B, Student, Student C, and Student A getting picked. It is still the same group of students. In contrast, choosing officers president, vice president, and secretary from a class deals with permutation. Student A becoming a president, Student B becoming a vice president, and Student C becoming a secretary is different from Student B getting the president, Student C becoming vice president, and Student A becoming the secretary. It is still the same group of students, but what they got are different. What they got are specified and therefore do not fall in combination.
We have here a few suggestions wherein you must determine whether it's a permutation or combination. We will give you 10 seconds to think about the answer. We will now start. Here's some first situation. Picking a team of 3 people from a group of 10 is a combination or permutation. Timer starts now. The answer is combination. Why? This is picking big person A, person B, person C is the same as picking person B, person C, person A. Picking the order of the team does not matter. Therefore, combination is the answer.
Next situation. Listing your 3 favorite desserts in order from a menu of 10. Timer starts now. Oops, time is up. The answer will be permutation. This should be easy since it already states there that your 3 favorite listed desserts should be listed in a order.
Next is this. How many ways can we get an award that is first, second, third, and Third place among 8 contestants. Timer starts now. Time is up. So the answer for this situation would be permutation. This is because, for example, if Justin is the first place, Kate is second place, and Nicole is third place, it won't be a it won't be the arrangement. Um, the arrangement won't be the same if Nicole is first place, Justin is second place, and Kate is third place. That is why it is permutation because the order of the winners is necessary.
Okay, if you're done, you can wrap it up. Are you done? Anna Faith?
Wait, but we have a last situation, but one of our teammates is facing is having technical difficulties. Po.
Okay.
On to the next situation, choosing 3 desserts from a menu of 10. We can now start analyzing. Timer starts now. The answer is combination. Since the arrangement is choosing 3 desserts out of the menu is unimportant.
This is the fourth situation. Total number of flights in a day. Timer starts now. Time's up. The answer is combination again. This is because the scenario is asking about the total number of flights, which in this case, the arrangement does not matter.
Last but not the least, there are 5 airplanes scheduled to take off at 4 a.m., 7 a.m., 11:30 a.m., 2 p.m., and 5:30 p.m. What is the answer? Time starts now. The answer is permutation. The type of the five airplanes take off cannot be shuffled. That is why this is permutation.
Um, so we have permutation, how to solve problems using this number technique and differentiate permutation from combination. We hope you have understood something from what we have discussed. Is there anyone wanting to uh, ask some questions?
Okay, so since no one is asking question, can I ask you this? Or not ask, but the same way that I did to the group of John Rain, right? Can you go back to, I do not know how many questions there are. There are, I think, five questions, no? That's the last question presented by Tolentino. Can you answer? If they are answered by combination, can you answer in numbers, no? If the one of those questions is answerable or answer can be answered by a combination. Can you go back to those questions? At least two, I think. No, I heard that the questions were answered by combination. And then can we have someone from you explain what could be the combination, no? Answer for that one. Okay, anyone?
So this is one of the examples po which has combination as which can be answered by combination. So our n po is 10. So is 10 and our r is 3. So that would give us 10 factorial over 10 minus 3 factorial, 3 factorial. Excuse me po. So 10 minus 3 would give us 7 factorial, and our equation now would be 10 factorial over 7 factorial, 3 times 3 factorial. So that will give us 10 times 9 times 8 times 7. We'll stop at 7 so that we can cancel the 7 in the denominator. So that will give us 3, leave us with 3 times 2 times 1. 10 times 9 is 90 times 8, that would give us 720 over 6. And now the answer for that would be 120. There are 120 ways for us to choose 3 desserts from a menu of 10.
Okay. So I hope no you got that from Anna Faith's explanation. Another one, please, since we do have plenty of time still. And I moved actually your quiz, right? So you have to take your lunch first. It will be unfair for you. Your stomach might ache. Okay, so after this period, math period, 12:30 to 1:30, you enjoy your lunch, and then you go back 1:30 to 2:30, time for your quiz. Okay, let's have, who will explain that? Would that be the same? It's 120. Picking three people out of 10.
Sir, it's the same po as the one that Anna Faith answered po. The three desserts. Picking three desserts po ba yun?
Yes, all desserts, and that one is creating a
From
team out
discussion
of
and with the given numbers.
okay, creating a team of three people, no? Out of how many people? It's 10 people. It's the same, right? Okay, 120. Okay. Okay, so far from the audiences, can we have a question from you if you want? Okay, none. Okay, I see to it, no? I will see to it that the link of your presentation, I do not know if you use, oh, yes, of course, your PPT is there, no? Okay, we cannot send that, no? We all know that, right? That if it's too big, we cannot actually send it direct to our messenger, and it should be shared. Was it shared?
Yes po, sir. We can send the presentation directly to Messenger po.
Okay, kindly do it now so that they can refer to that also as quick as they can. So it's page 272 mentioned by them. I also checked it, 272. Okay, so I think that you have distinguished or determined, know what's the difference between permutation and combination. No? There are cans there. How many ways can we arrange different cans? No? How many ways? It's permutation because there are 10 different cans there. No? But if we combine, that is their topic. No? Okay, we combine out of how many? No? It's 10 cans. We combine 3. Okay, we select 3 only from out of those 10 cans. And that is combination. No? We are combining 3. Okay, you must know. No, it's basic. Okay, if you want to be actually learning more about permutation and combination, you go to your textbook. No, do not refer to any other resources, but to just go there in your textbook and read them easily. No, the introduction will tell you. It is easy. Okay, 10 minutes more. So I will not give feedback. No, so it will be so unfair to all groups if I'm going to be giving feedback after the reporting is done. Why? Of course, there are other groups, no, that will still report, and with those feedback, of course, you know what I mean, right? Okay, they will be more better than you, no, the ones who did the reporting. Did you get that? Okay, I will not give feedback. Maybe after all of you groups have done their sorry have did their reporting. That's the time I give feedback in this reporting. Okay? So it's 12:21. So again, read your chat box. Okay, I need not to actually uh, repeat that. Okay. Okay. So alarm your clock. Set alarm in your smartphone rather. No, 1:30 to 2:30 p.m. That's 1 hour. Well, it's up to you if you want to seek help. And then the pass for this combination. So good luck to the audiences or to the audience, singular, but it's a collective noun. Okay, and of course, the group of Anna Faith will not take the exam or the quiz rather, no? The announcement also, monthly exam for month is not on Monday. I think I will give that on Thursday because I'm thinking you should have, kawawa naman kayo. Pahirapan ko pa kayo. Word problem na ba? Okay, sige. Will adjust, no? Okay, that's the good thing about monthly exam, no? Teachers can move it, no? It depends kasi uh, on the lessons really, no? Being tackled already and additions, no? Additions to those lessons. It's up to the teacher, no? They can move it. They do not question them, huh? Monthly exam. Periodical, it can never be moved. Okay, that's the difference. 1223. Okay, someone ask from you, no? You're not asking kasi eh. Okay? Okay, don't think of you, no? Asking questions. Ibig sabihin, no, it really means that you're interested with the topic of the group. That's why you're asking questions. That's why, no? Okay, and then, do you think I'm not giving you scores, audience? Sorry, hindi kayo marunong, no? Okay, parang pagbibo. Okay? Kasi si Nyampong, nandyan ba siya? Okay, counting 35 kanina. Absenan ko tong mga to. 31 na sila. Tayo. 31, I'm using 2. It's 29. Okay. 29 plus, okay, 29 minus 2. Mga to, ha? 27 na nandiyan. Okay. It's for clarification, and I do not think if you listened, if you attended the PTC, no, way back, first PTC with your parents, one of the achievers asked me this, no. Okay, one of the achievers, of course. How many achievers do we have in quarter one? Sir, ano pong award? What award will I get if in case, no? Of course, if in case you still have two quarters, no? Quarter 3 and 4, and quarter 2 is not finished yet. Of course, we cannot say kasi no that we can do it, no. If I'm an achiever, there's no certainty, no. There's no certainty that I could be consistent in having this achiever, no. Okay, merit in me. Okay, finishing the 4 quarters. Okay, ang tanong niya, sir, what award could I get, no, if in case I fail to, no? I fail to for the achievers kasi they should not be dropping, no? They should not get 89 below in all subjects, 90 above. You will have that the award that is what we call, it's no longer sorry, Academic Excellence Award, no? Academic Excellence Awardee, no? Pertaining to that person. But you'll get special, no? Or a special child. Okay, kasi nga, karoon ka ng 89 down. But make sure that the general average, you know, after that 4 quarters, general average, pertaining to general average, it's 90. No? I made that clear to the parents. Okay? You still have, of course, the medal. Special Academic Excellence Awardee. Did you get it? Okay. And for those who were not ranked, no, who were not achievers for the first quarter, like, I knew there are few of you, not few, but parang it's plenty of you, no, who got that 89 average or 90 even. You qualify for that Special Academic Excellence Award, you know. Why? Because come to think of that general average of yours, if it's 90 or 89, but you're getting or you got 89 below from one or two of those 8 subjects, then you qualify for that. No, just maintain that. Did you get it? Okay, don't you want to actually move up? Okay, without any award? Okay, it's possible for everybody, no? Okay, check your average. Naintindihan? Okay, it's clear for everybody, huh? Okay. You were not achiever, but hello, you have your goal, no? Okay, your goal is to have the general